Good morning. My name is Mr. Avdut Nilkanta Deshpande. I have 32 years of experience in the field of education, out of which 15 years experience for the post-graduation in environmental chemistry, 15 years for undergraduate chemistry, and 15 years for a secondary and higher secondary level. I am going to teach the maths and science for secondary as well as the higher secondary level and the chemistry in the Rugved Academy. Rugved Academy is situated in Kothur and it is near Bhatova Mandir. Now I am going to teach something about the basic principle of organic chemistry. Now, whenever we consider the basic principle of organic chemistry, it is first thing that we should learn that definition of organic chemistry. So, what is organic chemistry? Organic chemistry, it is a branch of chemistry. It is a branch of chemistry which deals with the carbon and carbon compounds. So this is the basic definition of the organic chemistry. Now when we say organic chemistry, it is a compounds chemistry of carbon and carbon compounds. So let us have some basic information about the carbon. What basic information we should get? First thing, its atomic number. Its atomic number is 6. The second what basic thing we should know? Its electronic configuration. That is 2 and 4. This is in shell form. For if you want as far as the orbital form, it is 1s2, 2s2, 2p2. This is K shell. This is L shell. So this is this is in shell form electronic configuration, and this is orbital form. So when we say this, we can see in the last shell there are 4 electrons. Now these 4 electrons that can be exchanged or given out or accepted. So that means its valency is 4. So all the carbon compounds, saturated carbon compounds, they are having valency 4. Now when we say valency 4, then next come the types of compound or the types of carbon compound that form, or the types of bond that it forms. First, that is, it forms covalent bond. Now, why covalent? That is very, very important. Now, why, and again, why it forms a bond? That we should also know. Basically, it follows the octet rule. What is octet rule? Every element to try to achieve noble gas configuration or 8 electrons in the outermost shell. Now if we see the carbon, the outermost shell does contain 4 electrons. So it has 3 possibilities. One, that is either accept 4 electrons or donate 4 electrons, or share. So these are the 3 possibilities that carbon should have. But carbon, if you can see the first option, there is 4 electrons that you accept. Carbon is not that much electronegative, so it can accept the 4 electrons. So this possibility is not possible. Now next, that it should donate the 4 electrons. But carbon is not a electropositive element, so it cannot donate the 4 electrons. So what left is to share. So that's why it undergo the covalent bonding. So what is covalent bonding? It is nothing but mutual sharing of electron pair. So that's why all the organic compounds, they always undergo the covalent bonding, and that is some on that whole organic chemistry is based. So as far as the types of compound is concerned, let us see now the types of compounds. Now, all the organic compounds basically contain carbon and hydrogen. The basic compounds of the all organic compounds contain carbon and hydrogen. So we can call it as a hydrocarbon. We can call it as a hydrocarbon. Now let us find out the types of hydrocarbon, or we can classify the hydrocarbon. There are two main compounds, hydrocarbon. That is saturated hydrocarbon and unsaturated hydrocarbon. What is saturated hydrocarbon? These are the hydrocarbons in which the valency of carbon is completely fulfilled. So they have the single bond always. So saturated hydrocarbons are the hydrocarbons in which there is only CH single bond, and that is a sigma bond. We are going to see what is sigma bond and pi bond afterwards. So this is the saturated hydrocarbon in which there is only CH or CC single bond, while unsaturated hydrocarbons are those in which there is it contains at least one double bond or triple bond. That means the valency of the carbon is not completely fulfilled. So this is a broad way. There are two different types of compounds, saturated hydrocarbon and unsaturated hydrocarbon. Now, let us concentrate on the saturated hydrocarbon. Cyclic and alicyclic. What do you mean by cyclic and what is alicyclic? Cyclic compounds are those compounds in which both ends of the chain is closed. For example, like a triangle, or when we say triangle, rectangle, or the hexagon, where all sides are closed. So that type of compounds are called cyclic. While the when both chains are open, it is called as the alicyclic or open chain compounds. The example for cyclic compound is this is propane. You can see any end, all ends are closed, so that's why it is called cyclic. And in the same compound, if I write like this here, see here, see the difference here. Here the both end, this end and this end is open for bonding, but here it is closed. All things are closed. So that's why this is cyclic and this is alicyclic or open chain compounds. Okay. Now when we say saturated hydrocarbon, we should know its general formula. Its general formula is CnH twice N plus 2, where N stand for the number of carbon atoms. For example, so we start with the put N is equal to 1. If we put N is equal to 1, what will get? CH2 into 1 plus 2, that is CH4, because 2 into 1 is 2 plus 2, that is 4. So CH4, this is known as a methane. Now if you put N is equal to 2, it will be C2H6, that is ethane. So in this way we can have a methane, ethane, propane, butane, pentane, then hexane, heptane, octane and nonane and decane. So for as far as the 11th is concerned, till decane is even limit. So so these are the all saturated hydrocarbons. Now while we are going to discuss about nomenclature afterward, but here I am going to tell you that if it is an open chain, then you can say methane, but if it is a cyclic compound, you have to use the word cyclomethane, cycloethane, like this. Now let us consider the second part, that is unsaturated hydrocarbon. As far as the unsaturated hydrocarbons are concerned, again they are classified into two mainly it is two, that is alkene and this is alkyne. Now a saturated hydrocarbon is also called as a alkane. Okay, alkene and alkyne. Now on which basis we have the classification alkene and alkyne? The differentiation is based on the double bond, whether it is presence of double bond or triple bond. Alkene contains double bond and alkyne contains triple bond. Now the general formula for alkene is CnH twice N, while the general formula for alkyne it is CnH twice N minus 2. Now let us take example. For example, we take N equal to 2, it is C2H4. 4, that is ethene. The same compound here we call it as a ethane. Now it is we are calling ethene. Then same thing if you have a triple bond, ethyne. So we can draw its structure also here. So it contains double, that is ethene, and this is ethyl. So we have the basic differences we have seen. Similarly, when alkene is present in a cyclic form or closed chain form, it is called cycloalkene. Same case for the alkyne. When it is in closed chain form, it is called cycloalkyne. Now, having said this, now let us go for its nomenclature. Now, when we consider nomenclature of the hydrocarbon, there are main two. First one, common name, and second, I.U.PAC. It should be I.U.PAC. You should not pronounce IUPAC. It is not IUPAC, it is I.U.P.A.C, because its full form is International Pure and Applied Chemistry. That something governs this nomenclature. So whenever we say IUPAC, it is IUPAC. We have to say IUPAC, not IUPAC, and it is a common name. Now let us see one by one. Now we will see the nomenclature of alkane. The first thing, that is common name. Okay, what is in this? In this, you have to count just number of carbon atoms, and based on that you can give the name. But in this, there are some two more terms are there, but as the examples we will see, you will understand what is that. So let us take one example. Okay, what I said to you, I said count the numbers of carbon atoms and give the name. For example, how much carbon atoms are concerned? 1, 2, 3, 4, 5. If the number of carbon atom is 5, then it is a pentane. Then it is a pentane. Okay. Now, here while we giving the name, it is not normal pentane. It is not a normal pentane, because here at the second carbon atom, there is side chain, we have one CH3 group. So it is called isopentane. That means when the substituent or functional group present at the second carbon below or above, then it is called iso. Okay. Now, had it been in case, if it is again CH3 here, it would have been neo 1, 2, 3, 4, 6, neohexane. That is when the substituent or the group present at the second carbon below and above, then it is called mu. So, in common nomenclature, what we have to see first, calculate the number of carbon atoms. Then see from either of the side whether any side chain present or substituent present at the second carbon atom. If it is second carbon atom, then it will be either iso. If that second carbon atom below and above the substituent, then it is called mu. So this is something what we learn as far as the common nomenclature. Now, next thing that we learn is the IUPAC nomenclature. Now, when we say IUPAC nomenclature, as I already told you, it is International Pure and Applied Chemistry. So here, let us see. First, we take the example directly so that it's simpler to explain. Okay. Now, first rule that you have to select longest chain possible. What do you mean by longest chain possible? It means that chain should contain maximum number of carbon atom possible. So that is one thing that you should understand. Okay, now let us find different way of chains. Okay, so first thing is take straight. This chain we preferred. So count how many carbon? 1, 2, 3, 4, 5, 6, 7. So straight. First, we get a 7. Okay. Now, we start from here. For ourselves, we do it with this cross. You can make any mark. Cross, where 1, 2, either 3. This is 3. But, so this is by second, there are 3. Now, suppose if we instead of going up above, we start right side. There is 3, 4, 5, 6. 6 carbon. So amongst this, which contain maximum number of carbon atom? This first that we chose that way. It contains the maximum number of carbon. So we have selected this chain. Normally, student have the should have the pencil with you while doing this type of thing, because once you select this, you should mark with the pencil on this chain that you selected. Now, when we select this chain, that means rest of them are substituents. These are called substituents. There is a basic difference between the substituents and the functional group. Substituent never changes chemical properties or not gives the identity. Just substituent gives the changes the physical properties. But functional group gives the identity as well as decide its reactivity. So I am calling this as a substituents, not as a functional group. So these are the alkanes. So these are the two substituents. Okay, now once we decided that it contains the 7 carbon atoms, that means it is heptane. Write down. Heptane. Okay. It is a normal heptane. Okay. Now you have to give lowest possible number to the substituents. You have to give lowest possible number to the substituent. From which side you start, that doesn't matter. Suppose if you start from this side, left side, it is 1, 2, 3. If you start from right, 1, 2, 3, 4, 5. So if you take from right to left it is 5, and from left to right is 3. So left to right calculation is accepted. So 1, 2, 3. So it is at substitute at 3 position. But there are two are substituent. So 3, 3 die. Now CH3 methyl, when one carbon is less, it is called methyl. When ethane, one hydrogen is less, it is called ethyl. So it is it is 3, 3 dimethyl and heptane. So name of the compound is 3, 3 dimethyl and heptane. Okay, right. So this is how you name the alkane. We saw common as well as the IUPAC. Now we are going to see something again for the nomenclature for alkene. So, what is the general form for alkene? CnH twice N. Okay? Right. Now, for this also, there are two methods, that is common nomenclature, a common name, and second, IUPAC. Nomenclature. So let us see for something about first the common name. In case of the common name, here also you have to calculate number of carbon atoms, irrespective whether it is below the chain or above the chain. Only thing is, if there is a substituent present below the chain, then that will be called iso. That's the only difference that we see in case of alkane. Same is applicable here. So let us start with the compound. Okay. Now, what really we are going to see first in this, that is the number of carbon atoms. First one, that is 1, 2, 3, 4, 5. So 5 means it is pentene. Sorry, 1, 2, 3, 4, 5, 6. So it is a hexene. Now, is it a normal hexene? No. It is, we can see that is a 1, 2, that is second carbon below, that is a substitute, that is CH3. So it is a isohexene. It is a isohexene. Had it been a, instead of this, one, two, three, four, five, six. This is a normal hexene. Had it been this compound, we would have called normal hexene. So these are the two different way you can have, either in normal or iso. Okay. As far as the this alkene is concerned, the neo compounds hardly found. Now we will see its IUPAC nomenclature. Okay. Again, the same rule we follow. First, we will draw the structure and then we will see rule one by one. How to name it. Okay. Now, since it contains the double bond, that means it is a alkene. For IUPAC nomenclature, again, you have to follow the same rule. What is that same rule? That select that chain which contain the double bond and maximum number of carbon atoms. It's not only the number of maximum number of carbon atoms, but you should select that chain which contain the double bond and the maximum number of carbon atoms. That's something we need to see. Now let us, as earlier, we will follow the different paths. Path number 1. We will follow straight 1, 2, 3, 4, 5, 6. Oh, okay, if we say takes this way 6. Okay. Now if we try to see this way 1, 2, 3, 4, 5, 6. Okay. Either of them case we have the maximum number is 6. So any of we can from any of we can calculate. That's not a big. Second thing is, here you have to give the lowest possible number to the double bond. So here we have the one, that is 2. So and a substituent, that is the 3, 4, 5. So 5 methyl, then hexa 2E. Now why 5? Because at the methyl at the fifth carbon atom and the double bond at the second 1, 2. So that is 5 methyl, this methyl, and 2 in hexa 2 in. So in this way we can nomenclature alkene.